A great way to get a sense of scale between these large numbers is to look at them as if they represented an amount of time, in this case seconds. So we'll say if you had 1,000,000 seconds or 1,000,000,000 seconds, how much time has passed. So I would just take a moment and make a prediction. How many days or how many years do you think 1,000,000 seconds will be, 1,000,000,000, and so forth? How close will they be together? Because if you stop and do that, you can test your intuition against your calculations and see just how you're perceiving the scale of these great numbers. So let's start with the basic calculations of how many seconds are there really in a day. So here, if we have 60 seconds in every minute, 60 minutes in every hour, and 24 hours, we can multiply those three to get our answer. And there we have it. Every one day that passes, that's 86,400 seconds. So if we have 1,000,000 seconds, right, what does that mean? Well, you can look at this and just estimate it right away. If I had 10 days, right, what would that be? Well, that would be 86,400 seconds times 10, or 864,000 seconds, right? Essentially, we're just adding another zero onto the number. And that means, of course, you haven't even reached 1,000,000 seconds. So right away, you can get the sense that 1,000,000 seconds is over 10 days. The exact calculation is fairly simple. We can just do 1,000,000, right, or 10 to the 6th I could have put, divided by 86,400. That'll tell us the amount of days it'll pass. 11.574, right? It looks like 5740 and then 740 and repeating, right? So we'll put 11.574. 11.574 days, and that is 10 to the 6th, or 1,000,000 seconds. So now here, of course, it's not a full year. We could find the fraction of a year by doing 11.574 divided by the average year length, which we'll say is 365.25, right? That's the average length, because here we're looking at the average of both full years and leap years, so it's average year length. So if you want to find out how much of a year this is, just take 11.574 and divide it by the total length of a year. In this case, it doesn't change the date in the past or the future. It would still be 2012 because we are in September. Now with 1,000,000,000 seconds, everything changes. Now the calculation, we can do 10 to the 9th divided by 86,400. But we know that if you take 1,000,000 and multiply it by 1,000, or 10 to the 3rd, we get 1,000,000,000, and that's 10 to the 9th. This means that a billion is 1,000 times larger than 1,000,000. So this is our number, 11.574 for days. Multiply it by 1,000, we get 11,574 days, and that's how much time would pass for 1,000,000,000 seconds. Now if we want to look at that in terms of years, all we do is take 11,000, right, 574, and divide it by the average year length, 365.25. And we get our answer, 31.68788,501 years, which is amazing, right? If 1,000,000 seconds is almost 12 days, that means 1,000,000,000 seconds is over 31 years. So this is quite remarkable, right? So if we're dealing with years, though, I would like to think about this a little bit more precisely in terms of months. We have 0.687, we'll round there, or let's say 0.688 months. So let's just go over here. So 10 to the 9 seconds is 31 years, and, well, I'll write the number out, 31.688 years. That'll help us, 0.688 years, and that is 10 to the 9 seconds. So what would this be in years? Well, we have 31 full years and then 0.688 of a year. So we just go 0.688 times 12, right? There are 12 months, and we have 0.688 of that. And that gives us a more approximate timeline, 8.256 months. So 31 years, and then, just to be precise, 8 months, and keep going, 0.256 of a month. Well, let's just assume the average, well, I don't know the average month length, and I can look it up, but let's say it's about 31. So 31 times what? Well, times 0.256. So 7.93 days. We can keep going in this process to get hours, minutes, seconds, and so forth, but I'll settle here for 8 days. So 31 years, 8 months, and 8 days. And that is a billion seconds, so 10 to the 9 seconds. So this is only critical, I think, in terms of when you're at in the year. So here we have 31 years, right? About 31 years. But that about really matters. If we're in September, right, think about that yearly cycle just for a moment, and I'll write this over here. September, right, to get to the next year, what does this mean? Well, 31 years would pass, and we still, if it was exactly 31 years, if we leaped ahead in the future 31 years, we would end up back in September each time. But we have a little bit left over, so we need to think, will that leftover going into the past bring us back an extra year? And is the reverse true? Going into the future will bring us ahead an extra year. So how do we do that? Well, again, just count, right? So here, so the future, next year, if you're in September, how many months is it away? Well, we have October, November, December, right? And then that's it. So we have, and then I guess if you're kind of from September, so September to October, October to November, and November to December, and December to the new year. So it's about 4 months if you're on September 1st. Going into the past, right, to the next year, what's going to happen? How many months have to pass? Well, working backwards, we have September to August, right? August to July, July to June, June to May, and I'm actually counting my fingers here. May to April, April to February, February to March. I did it backwards there. And March to January. Yes, and then January to the new year. We need about 9 months to get back, right, to the next year. That's counting from September 1st, right? And I'll just do that again because I don't want to make that mistake. So September 1st to August 1st, right? That's 1 month. August 1st to July 1st, July 1st to June 1st, June 1st to May 1st, May 1st to April 1st, April 1st to March 1st, March 1st to February 1st, February 1st to January 1st. Ooh, 8 months that time, sorry. So it's 8 months. And that makes sense because that is a total of 12 months in the year. Okay, so anyway, if we look at what this means, right, we have this measurement, 31 years and 8 months and 8 days, so a little over 8 months. So for us, being in September, not only do we go 31 years into the future and past, but we go a year further. So here, going into the future, we'll start with that one. 31 years exactly would bring us to 2043, but we're going to go to 2044, right? That extra year. And going into the past, right? What will happen? Well, this math we'll just do quickly here. Subtraction 2012, right? Minus what? Well, minus 31 plus a year, minus 32, brings us 1980. Wow. So from 1980 until now, about 1 billion seconds have passed. Remarkable. In a sense, that means if I look back at the past 12 days, I'm thinking about 1 million seconds. But I'm about 30 right now, and that means if I look back over my whole life, I'm at about 1 billion seconds. Quite a remarkable difference between 12 days and my entire waking memory at this point. And yet, when we look at larger numbers, we go even further in time. So here, if I multiply this by 100, right, that'll give me 100 billion. So that'll give me not just 316.88 years, that would be 10 to the 10th, but 3,168, right, 0.8 years. And that's for just 10 to the 11th seconds, right, or 100 billion. 2 powers of 10 larger than 10 to the 9th. And now that's just 100 billion. A trillion is 10 times larger than that. Multiply that by 10, and our estimation, right, is running out. We need more decimal digits to get a good representation of what's happening. So here we have 31,688 years. And that's just for 10 to the 12 seconds, or a trillion seconds, right? We're basically going back to the origins of mathematics. That's how far back we're going, or the origins of recorded mathematics. Now, a quadrillion is 1,000 times larger than a trillion. It's 10 to the 15th, right? Wow. So here, even if we had a better estimation, we still know right away it's going to be over 31,688,000 years. Now you can do the more in-depth estimation for each of these, and you, if you need to, get an exact result, kind of like what we did right here, right? Just breaking the decimal that you're given down further and further and further. You're given a concrete number of years, then estimate the number of months, days, and so forth. That'll help you figure out exactly how far in the past or future you're going. Now let's just estimate here, because that's part of the fun. I mean, here we have 100 billion seconds is almost 3,200 years, right? 3,168 years. So just doing the quick calculation, we're at 2012 right now, right? If we added 3,168 years, exactly, that brings us to 5,180 in the future. Wow. If we go in the past, right, we're at 2012 right now, so we subtract 3,168. This brings us into the negative, or BCE error, right? 1,156 BCE. Wow. 1,156 BCE. I mean, look at that jump. With a billion, we go back to 1980 seconds. The next jump is back to 1156 BCE. This is such a stark contrast. Think about what's happening at that time, how different the world was. Going back a trillion years, right? We go back 31,688 years. So in the future, we're at 2012 plus 31,688, right? The estimation there. That brings us to the year 33,700. Where will we be in that year, 33,700? Going back in time, right? This is amazing, because we go back in time here. We're going basically back way before all recorded history. 29,676 BCE. And the quadrillion, I mean, that is almost unimaginable, right? We only have slight evidence of what was around at that time. Well, I guess you could say abundant evidence, but from the perspective of what we know that happened in 1980, what we know that happened in 31 million years ago is not even comparable, right? It's essentially a mystery, a wonderful mystery in many ways. So if we look at 2012 and we subtract 31,688,000 years, where does that bring us? Enter that in, and did I enter it in right? 31. I did not. Sorry. Try that again. 2012 minus 31,688,000 years. 3 more zeros. There we go. So here, right, we're at the year 31,685,988 BCE. And going into the future, of course, 2012 plus 31,688,000, that brings us to the year, right, 31,690,012. The time jump there is just, it's hard to even comprehend for the quadrillion seconds there, the last stage. So anyway, what happens is, as soon as you start assigning a time value, you can look at these numbers and compare them to the timeline in your own life and get a real sense of just how much larger a quadrillion is than a trillion, and how much larger that is than a billion and a million. It's easy to say that one number is 1,000 times larger than the other, but it's hard to realize just what it really means in terms of scale. So I hope this helped. Thanks.